Hello friends. So once again welcome to my channel, and in this video we will see division for positive integers. The algo that we are going to use is called as restoring division algo. So we'll see how it works with one example, right? First we'll see the algo, then we'll start with the example. So see, before starting that example and algo, first I would like to show you how we used to perform division for binary numbers. Anyways, our integers are stored in binary form only, right? And they are positive integers. So now see, while doing it in that binary division, suppose I want to perform the division of 8 divided by 3. So what is 8? 8 is 1, 3 zeros will be there, right? And divided by 3 means it is 1, 1. So how actually we used to perform? How the machine will do it? What it will do? First, it will consider the first bit of the dividend. And then this 1, 1, this 3 will be subtracted from this 1. And we know when we subtract 1 by means we'll subtract from 1 your 1 1, then we are going to get what? One negative result. And when we'll get negative result, that means the division was not successful. So this particular bit of your dividend is contributing 0 in the quotient part, right? And after doing the subtraction, we used to keep the result in this particular position only, right? So whatever we have done the subtraction, we will nullify that. Then what we used to do? We used to consider the next bit of the dividend. That means 2 bits next we are going to consider. Actually, see, we are so used to with all these things, we do it automatically. But how the machine will do? Machine will take first the first bit. If it is possible, good. If it is not possible, it will consider the next one more bit. Using 2 bits, it is going to perform the subtraction. So now it is what? 1 0. From 1 0, if I subtract 1 1, 1 0 is what? 2. 1 1 is 3. Then also I am going to get a negative value. That means here also my subtraction was not successful. So it is contributing 0 in the quotient bit. Then next, what I will do, I'll consider one more bit of the dividend. So now it has become what? 100. 100 is what? 4. So from 4, I need to subtract 1 1. So 1 1, if I'll subtract, then what it will become? It will become 4 minus 3 will become 1 only, right? So it has become 1. Now with this one, we will do, again it is not possible. So next I'll consider this one more bit, right? 1 0. So this 1 0, when see this one, this success here, my subtraction was successful. I got a positive value after subtraction, maybe 0 or any positive value. Anyway, positive value will be 1 only because it is binary. So here it is 1. This 0 in this position, the quotient bit contribution is 1. Next is this 1 0. So see, with this, with 1 0, if I'll do this subtraction, it is not possible. So it will contribute to 0. And there are no more bits are left in the dividend. So what does it mean? This is my quotient and this is my remainder. So if you see this one, this is nothing but 2. And this one is also what? 2. So 8 divided by 3. What we know? The answer is the quotient is 2 as well as the remainder is 2. So this is how the division operation on binary works. Whatever I have explained this one, this only we are going to use in our restoring division algo. So we'll see how it works, right? So see, first we need to initialize our the whatever operands we are using and all. So first initialization phase says a equal to 0. That means one auxiliary register we are going to use. There we are going to keep the value initially as 0. So how many zeros will be there? Whatever is the length of your operands. And do understand, using equal number of bits, we are going to represent both our dividend and the divisor, right? Using equal number of bits. And A will contain that many number of zeros, whatever is the length of your operands, right? Then Q will contain the dividend, and M will contain the divisor, and N will contain the number of bits in the operand. That means how many times I am going to perform that cyclic operation. So that is nothing but the number of bits in your operand. Both operands contain same number of bits, so we are not mentioning dividend or divisor, only operand. Then how the algo works? See, one more thing that already I have mentioned, both your operands Q and M are positive integers represented using equal number of bits. And one more thing, in A, one extra bit is considered to keep track of the sign of the result of subtraction operation. Just now I have shown you, while doing division, we were performing continuously subtraction operation, and we are checking whether the result of subtraction is positive or negative. If it is negative, the quotient bit was set to 0. If it was positive, quotient bit is set to 1. So see here. So because of that, the sign bit is important. Looking at the sign bit, we used to set the quotient bit after a subtraction operation. The next is, now we'll see the algo. The algo says shift A and Q left one binary position. A and Q together we used to take them as a single operand. And see, initially it contains what? All 0 0. Suppose it is 8. So this is 8. So now see how we have done. First we have taken this 1. So what we have done? Shift A and Q left one binary position. So this 1 will come here, right? And here it will be 0 and this position will be vacated. This is 0. So now from this 1 means 0 0 1, what we will do? Subtract M from A. So what we'll do, from this A, we'll subtract our divisor, that is that 3, and we'll place the result back in A. So A will be now modified. And after doing the operation, we will see the result is a negative quantity, right? So see here, and one more step you understand. Here we used to perform subtraction operation. Subtraction operation is nothing but adding the 2's complement of the divisor. That is equivalent to performing the subtraction operation. So we'll perform subtract m from a by adding the 2's complement of your m with your a, right? And we'll place the answer after doing the operation. Result will be placed in a. Then what we will do? We'll see the sign of the result. So if the sign of A is 1, then what we'll do? We'll set our this result in one particular bit, that Q naught, to your 0, because the result is a negative quantity. So quotient contributed will be 0, and this is fine. Else what we'll set? We'll set the quotient bit to be 1. That means the result is positive. And one more thing, whenever we are getting a negative resultant, then we will nullify the operation. After subtraction, here the result will be there. That means it is a negative value. But this then due to the negative value, quotient bit is set to 1. Now we need to repeat our process. Next time what you need to consider? 1 0, because 8 was 1 0 0 0. So now next I'll consider 1 0. So this 1 is already there in A. This 0 will be also taken, right? So see, but now A has been modified by the subtraction operation. So we will perform the reverse of subtraction, that is addition operation, and we will get back my previous A. What was my previous A due after, sorry, before subtraction? It was 0 0 0 1. So here we have got the result of subtraction. It is a negative quantity. So now I need to nullify the operation, and I need to consider one more bit from Q. So for that, to nullify this result, we perform another addition operation. So minus plus will cancel each other and will take me back to my original form. Understood? And then we repeat the process. We'll take this 0 here and we will repeat. So see here, if the sign of A is 1, set Q naught to 0, add M back to A. This step, because of this step, the name of the algo is restoring. Whenever we get a unsuccessful result, that means the contribution of my quotient bit is 0. That means the result was negative. That subtraction was not successful. So we will nullify the operation by performing a addition operation. So we'll perform A plus M, right? Else means the A bit was 0. So Q naught bit will be set to 1, right? So whatever we have seen there, kind of similar to that, our restoring division algo is. The next one is, we will repeat these steps n number of times. What is n? The number of bits in my operand, right? And at the end of n steps, where will be your result? Your result will be two quantities. One is quotient, one is remainder. So the content of Q after n number of steps, The Q content is representing quotient and remainder will be there in register A. Both will be of NN bits. So result will be in Q register, that is quotient, and remainder will be in register A, right? It is also of N bits. So this is the restoring division algo. Hope the algo is clear. Then in my next video, I'm going to explain the one example using restoring division. Algo, we need to remember, it is very similar to whatever we have seen, that division of binary numbers, whatever we used to do means ourselves only, that we are showing here in the form of an algo. It is kind of similar to whatever we used to do. Whatever subtraction we have done, we have to nullify if it is not contributing a your quotient bit, right? That is, it is contributing a 0 in the quotient bit because the result is a negative quantity. So we will see our example in the next video. Hope this explanation on the algo is clear. Then till then, thank you, and we'll come up with the next video in the example. Thank you.